Right, let's bring on the rain, and I'm going to use the same approach for this that I used for the last two icons, so go back and check them out if you want to know how we're doing this in general. But you can see I've got my rain element there with a frame of 400, and if we scroll up to the top, I've got a config for the rain layout set up on line 5 already. You can see how that layout guide looks in the preview right there. I've got these 3 rails that I'm going to use to put our raindrops on. There are several other ways we could do this, which we'll look at the end. If you're not familiar with layout guides, I've done a series on them, so watch that if you want to be brought up to speed or if you find any of this confusing. So remember, this is going to be size agnostic, so that means that the raindrops themselves, or at least the stroke that we're going to be putting on these raindrops, also has to be dependent on the size of this frame. Let's put the rain shape inside a geometry reader. And if you're not familiar with geometry readers, I've done an episode on them, so you might want to check that out if you want to know more. So I'm going to put these statements in there, and then I'm going to put a stroke on this with a color of blue and a style that has a line width of GO, width scaled by 0.07. The line cap is going to be round. The line join is also going to be round. We don't need the rest of these. And then we can resume and get down to the business of building our rain. So let's bring the rain shape into view. And the first thing I'm going to do is lay out the layout guide config. Rain layout config laid out in our rectangle. The other most important thing is going to be the Y offset per row. Let Y offset per row be equal to the height scaled by 0.35. And now when we're iterating through our raindrops, we can use that. So I can put in a for loop here for row in 0 to 2. Let the row Y offset be equal to the row that we're on as a CG float multiplied by the Y offset per row. So that's going to give us how much offset we're getting. And obviously for the first row, that will be 0. And now comes the cool bit, because we can take our layout guide, shadow it with a local copy that is offset by that amount, and then just use the layout guide as normal. Let the local G here be equal to the original G with a Y offset equal to the row Y offset. And now anything I draw is going to be offset by that amount. And here come our raindrops. They're going to be lines that go from and to a point. And the X coordinate in the layout guide for those points is going to be based on the vertical rails you can see in the preview. The Y is going to be a relative Y. We covered this in the cloud episode, so go back and watch it if you don't know what that is, but it should be fairly obvious from what we're doing. Let's put in the first raindrop. Path, line, and we're going from to here. So we're going to say the first point, the X coordinate is going to be 0, and the Y coordinate is going to be relative to the rectangle on which the layout guide is based. So in this case, I'm going to say that's 0.12. It's going to, again, an X coordinate of 0 and a Y coordinate of relative 0.29. And look at that, we've already got 3 raindrops. Let's put in another one. But for this one, we're going to say that the X coordinate is actually 1. So we're going to be using the central lane. I'm going to change up where this line is from and to, just to make things look a bit more random. So in this case, I'm going to be going from 0, and I'm going to be going to 0.15. Let's put the third column in. We're going to say that instead of 1, it's 2, and the relative values are going to go 0.05 all the way to 0.2. And because that's so simple, you can really explore your creativity here. You can change how long they are, you can change the spacing between your drops, you can change the row height, and you can put more drops in. It really is up to you. And compared to the native version, which can be quite intimidating and wouldn't want you to increase the complexity any more than it already is, it's a much more declarative way of working and therefore simpler. Let's make the rain animate, and if you're not familiar with animatable and animatable data, I've done an episode on animating points within layout guides where I go into a lot more detail, so it would be worth watching that if you're not familiar with these concepts. So let's put on our animatable data, which is a CG float, and I'm going to put in an initializer, so we just have to tell this thing whether or not we're raining, as opposed to interacting with animatable data, which is an implementation detail. Init, raining, which is a Boolean, and we say the animatable data is equal to 1 if we're raining, and 0 if we're not. So animatable data will iterate from 0 to 1, and as rain shape is re-rendered over and over again with different values of animatable data, we can use that to drive our animation. And we need to tell this thing if we're raining, so let's go to our rain view and put that in. We've got a raining variable here, which is false to start with, and then when this thing appears, we give it a linear animation with the duration of 1. We repeat that forever with auto reverse set to false. Raining is true now, and then we pass that in here. Raining is raining. Okay, let's resume and go down to our shape. How are we going to animate this thing? Well, very easily indeed, because we've got a layout guide and we can animate the position of that layout guide. Then the layout guide that is generated from it on line 51 is also going to be animated. So there will be an additional offset based on the animation. All I need to do is say that the original layout guide has a Y offset that is equal to the Y offset per row, but we want to base how much of that offset we're using on the value of animatable data. So the factor is the animatable data. So when it's not raining, it will be in its original position, and when it is raining, it will be in this position you can see here. And I can change that value to say 0.5, and you can see it's halfway through the animation. So that means if I play this, it should just work now. Absolutely fantastic. But they're popping in at the top and popping out at the bottom. What do we do about that? We obscure it, and I can show you what that looks like by just updating our preview. So I'm going to put this in a Z stack. Underneath our rain element, we'll put a V stack and a capsule in there, which we're going to fill with gray, and the height of which is going to be 130. And then to shove it at the top, we'll put a spacer in there. There's our cloud, and then we can constrain the whole thing by clipping it to a rectangle. Clip rectangle. There we are. And now if I play, you'll see that this rain gives the illusion of permanently raining, and it's not popping in or out. So that's what we're going to do when it comes to putting it in a composite icon. Now, I did mention there were other ways of doing these columns of raindrops, so let's look at a couple now to see the flexibility that we've got here. Let's go up to the top, and instead of explicitly stating the columns, let's just put 2 columns in. So we've got 2 columns and 3 column separators that we can use for our coordinates. And that's why we're getting the result we're seeing here. But we have options, because we can scale the rain shape before we stroke it in the X direction, for example. So we can set up our raindrops and then go to our rain shape and say X scale 0.5. And as you can see, it's scaled the shape itself in the X direction, but the stroke is still applied and has the same thickness because scaling a shape returns a scaled shape, which you can then stroke. We have another option. We could ignore the coordinate system in the layout guide entirely, but still benefit from the fact that we can animate layout guides. So I can get rid of that, go down to our shape, and then ignore the coordinates. So instead of G0, I can use a relative coordinate of 0.3 instead. We can go to the last column of raindrops and say that that goes to a relative value of 0.7. And now we're in exactly the same position because we defined our original columns as having relative values of 0.3, 0.5, and 0.7. So lots of flexibility there. The world really is your oyster when it comes to this kind of thing. If you want to have a look at the source code, I'll be providing the source that we're going to be using going forward, as well as the native version of this, if you really want to see how it would work if you didn't have the benefit of layout guides and everything else that PureSwiftUI has to offer. So have fun there, and in the next episode, we're going to be pulling all of these elements that we've done so far, the cloud, the sun, and the rain, into one composite icon. We're going to be moving them, scaling them using the element views, and we're going to be controlling the animations and how they're appearing in the main icon view. So join me for that. It's going to be brilliant. If you're enjoying the journey, let me know by liking the video. And if you don't want to miss the extraordinary conclusion to all of this, consider subscribing if you haven't already. If you have any questions, comments, or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.